We're live and let's continue solving our tasks. So let's check. All right, so first, the definition. Given two strings, S and T, on lengths M and N, respectively, we have to return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return empty string. The test cases will be generated such the answer is unique. All right, so we are given two strings, and we have to return the minimum window. So it should be some string of S, so that every character in T include duplicates. So, for example, we have ABC, right? And B, A, and C. Yeah. So minimum substring that contains all characters in T. All right. So let's first. So we have, so we have S and T. So it's strings, and also, and we have to return another string. Let's say result, and it would be the minimum substring from S that all T characters included, the minimum substring. All right, so let's first understand what would be the S and T lengths. So let's say that we have at least one element, and it would be 10 in 5 power. It was given, and also STI. So it means that value, it's all consist of uppercase and lowercase English letters. So it would be like 26 plus 26. It would be 52 chars. Okay. So yeah, so I think that's the main point here. So let's think about some test cases. So if, for example, so we can just directly check. So if S, for example, A, and here B, it would be BA, then we should just return an empty string here. It's first test case. Another test case, for example, if we have AA, and here we have AB, it's as well because we don't have any B. And yeah, I think that's pretty much all that we need. And another test case, for example, you have A, and here we have AB. So in this result, it would be A. Oh, sorry, we have A here, but B here. Yeah, we see that it's going too close, so let's make it faster. So for example, we have AB here, and we have A. So result would be A because we can construct from first string another string. And what if we have, for example, here like ABB, C, and here we need AB. So the result would be also AB here. So the minimum substring. And yeah, that's pretty much. So let's think about approaches that we can use. So for sure, we need some kind of a map with duplicates. So we need a map with each character and how many times it exists, right? Then the second, we iterate over AD OB. So for example, we have this one, right? So we iterate, and when we see A, we actually should not stop here, and we should continue to check, because here we have B and then we have C. So actually we can have something like this, but it's not the minimum for us. It's not actually the minimum length. So the simplest approach, it would be 2 loops, but 2 loops, it would be TTL for us. So we need something different. So for example, when we calculate ADBC, we can have another, so here we actually stop. And here we need another pointer where we can find our A. So, for example, when we decrement our value and we see that, okay, so we decrement A, and then if we decrement A, we need to increment and find one more time. So we go. Here we have another B, and we go and we found. So this one also, this result would be enough for us. So we can start again decrement. So we decrement, then we have B, but B was added, so we also can decrement B, and we go to here, right? So here it would be our minimum, I mean, and we decrement C. So when we decrement C, we actually go, and then we found C. And now we can start decrementing, and we actually found a B. Okay, when we yes, we found C, and we can start decrement until we decrement B, and and this one would be the last test case. So I think something like this we can do with 2 loops and 1 map. One map. So first of all, we can construct a map. Then we can start iterating, and we should have also we should have current count. We should have count. Count, and also current map, where we put all our elements here. And when we have the equal element, we actually increment our counter, and then we can check if our counter is equal to map size. It means that we populate all values and we can start decrementing. We can start decrementing and then check results. So let's start to implement this. So we have a string result. It would be empty. Then we need a map with character and integer. Then we need counter. It would be 0. Then we need to iterate over t, char c, and t to char array. And here we do like map put c map get or default c0 plus 1. So we have this counter map. Then we iterate by I as length I++. Also, we can do one check. So if s length is less than t length, then we return result. And here we actually do this loop here. So we also need j and and also we need a while. So while counter is equal to map length, we start decrementing this. And also we need a current, we need another current map, car map. And here, if so we need the char. So on which char currently we? So currently we on s char at I, and we need to check if map get c is, if map get c not equal to null. And here we should put in our current map, put c current map get or default c0 plus 1. And if current map get c is equal to, is equal to map get c, then we can increment our counter. Yeah, we can increment our counter. And here, when we have all these counters, we can start building. So we need result and current result. Current result. So current result would be always yeah, we need some kind of deck in the queue. The queue with characters. Java the queue. Okay. And we add C, and then we need check which functions we have here. So we have add, poll first, and remove first, and add last. Pick first, remove first, pick first. Comparison of stack and deck. Push pop pick, add first. Okay, so we have first and last element, and we can remove first and remove last. All right, so let's check. So here, if count is equal, what we can check? So here, let's say result. Yeah, we need some maximum result. So if result is empty, like we can check length. So if it's equal to 0, then we just add to our result, add string, and we put here our deck. Yeah. Yeah, something like this, but yeah, I think run out of time. So let's solve it later, or let's check later how to solve it. I think it should be done much more simpler. Slide and window solution. Something like this, but yeah, let's check it later. Okay, that's it for today.